Generally, we'll use this one, At89c51, okay? At89c51. Can you see that one? You know, in this view, you can find the preview on the upper right corner. There is a preview of the component and the PCB preview on the lower right corner. Okay, and the package is DIP 440. Yeah, PLCC is this kind of PCB. Okay, but we'll use the first one. You cannot find. Why? You know, here first you need to select the category, or you can directly input the keywords At9C51. Okay, and enter. Input the keywords At9C51. Okay. Can you find that? The first one, At9C51. Then press OK. Then you have the microcontroller. Okay. This is one chip. At89.
Sir.
Yeah.
I cannot find the one you selected.
Why? Because we have this At9C51.
Oh, so never mind. I found it.
Okay. The name is here. Okay. At9C51. And if you want to move it, just click left click the component and highlight it. Then you can press your button, your mouse to move it. Okay. And if you want to, you know, here there is a small window here. Can you see that? There is a small window here. Is the current area. You can move it. Okay. You can press the button and move it to make it showing in a proper place. Okay. Okay, now this is only one microcontroller, right? If you want to use it, we need to add some external circuits. The first one is crystal, okay, or oscillator. So we'll go to the lab again and pick up it, okay? Oscillator or crystal. Crystal, do you know crystal? Here, I will give you a list for the components, okay? List. Input the crystal. You'll find the quartz or the oscillator, okay? Can you find that one? Crystal. Press OK. Okay. Now we need to rotate so that we can connect it to the microcontroller easily. Okay. Right-click it, rotate clockwise, okay, and move it to a proper place. Now when you move your pointer to the end, one end of the crystal, and then left click, you can find a line appearing, right? And click again when the line is close to the crystal 1 pin, okay? Can you see that? 柳生 do you find the components, the device? Okay, good. And now click another end of the crystal, okay? Next, because the crystal needs some extra circuits to make it work stably, so we need to pick another capacitor from the library. Capacitor, okay, capacitor. We can use the capacitor. You can use the short name CAP, okay? CAP. There are so many, and CAP. Generic. The category, you can select the capacitors, and the subcategory, please select generic, okay? Generic. And select the first one, okay? CAP. And rotate. And change it. And when you left click the component, there is a window coming out, okay? Can you see that? And the capacitance should be changed to be 30 pF, okay? Then you can copy to get another one. Okay. Now connect them together. Now we need to add one ground. Ground is you can check the shortcut on the left part of your screen. Terminals mode. Can you find that? Click terminals mode. and in the list you can find ground, and click it. Then in the current view, click again to get ground. Okay, then connect them together. Okay. Now we have finished the crystal part.
Can you show where to get the grant again?
Do you find the shortcut on your
Yes,
on the left? Click the terminals mode.
Oh, okay.
Terminals mode. Okay. Now we'll start to get another the reset part. Okay, reset part. We'll add another capacitor from the library. Click the component mode and click P. Press P to get the CAP gun. CP lock. Okay. Okay. Okay, now we will make it simplified so that we can quickly on the way to simulation. Okay, for reset, if you want to reset it, you need to use the high level. For the here is the VCC, right? VCC 5 volts, and now you need the elect capacitor. Okay, for the reset part. Okay, and you need one resistor here. Okay, that is what we need for the reset circuit. These parts are the crystal part, and this part is the reset part, reset circuit. Okay, so now we go to find the cap elect. Okay, cap elect. And we also need to find a resistor in the library. Click P and go to find the resistor. resistor. Okay, resistor. Because there are so many, you can click resistors and generic one. Generic one. Okay. Subcategory generic. Okay. And we need to find the power from the same place to ground. Okay, and power. Okay. Now we can is to add one LED, one LED. Okay, go to the library. No, we need to click component mode and click P to get one LED.
Teacher, you're going too fast.
Okay, so do you find the power? Actually, I will send you the recording and you can practice it. Okay.
All right then.
We can go to the library and get LED because there are several colors of LEDs. You can input anything you like red. Okay, you will get a red LED from the library. Okay. Remember that there are two ends of the LED. Okay, this end and this end. Okay, we will rotate to limit the current through this LED. If the current is too big, then the LED may be destroyed. Okay, so we need to use a resistor to limit the current. Okay, so we click the resistor because we have already add the resistor to the list. So just click RES and then add it to. This resistor cannot be too large. Okay, so we need to change the value of resistance to maybe 100 ohm. Okay, we use P1.0 to control it. Okay, for this LED, if this end is high level, this end is low level, then LED will be on. Okay, but if this end is high level and this end is high level too, then it will not be on. Okay, so we need to control P1.0 to generate a low level so that this LED can be on. Okay, but now all the circuits are already save it. Already, let me check the value for the capacitance. It's a yellow. Okay. Okay.
Sir,
if you want, yeah.
So what is the name of the component you connected to C3, the pointy one, like the arrow? The arrow with C3.
The arrow?
Left
you mean this
component.
one?
Yes, sir.
This one?
Yes, sir.
It's power. The VCC. VCC, you can select it from the same place to ground. Okay? click the terminal modes, and you can find the power and ground. Power is what you see as the arrow, okay? Now you finish all the connections of hardwares, okay? We need to do our programming. I have already sent you the hex file. We need to select that hex file. Select, okay? Use highlight the microcontroller, and then click again. You will find a window, okay? A window. And here you can find a program file. Select the hex file I sent to you, okay? Select the hex file I sent to you. And okay. Now we have finished all the parts. Just run it to see the result, okay? On the lower left corner, you can find a play button, okay? A play button, okay? Then you can find the flashing of the LED. Can you find that?
Sir, can you repeat the last part again, the hex file?
Hex file, okay. If you want to operate it, you need to pause it or stop it. Stop your simulation, okay? Then select the At89c51, the microcontroller, okay? Highlight it. Then click again. There is a window. In the window, you can find a program file. Can you see that? Program file. About 1, 2, 3, 4, 5. The fifth line.
Yes, sir.
And just click the folder icon. Okay. And then select the hex file I sent to you through WeChat. Okay. Do you find that?
Yes, sir, I got it.
Okay. After that, click OK. They can play it or run it by click the play button. Okay.
Yes, sir. My one is running.
Okay. Now you can see some blue and red squares for each line, each end or pin of the microcontroller, right? I see that some pins are have red squares on the line, above the line. Okay, I see that. Red squares means high level. Blue squares means low level. If you take a look at P1, you can find the level state of P1.0 are changing from 1 to 0 or 0 to 1. Can you see that? In this way, okay, I will pause it. Now P1.0 is high level, right? High level. And here is high level. So the LED will not be on, okay? And now P1.0 is a low level, output low level, right? And here is high level. So the current will flow from left to right. The LED will be on, okay? So if you want the LED to be on, you need to output 0 or low level from 1.0, okay? That is what we control by using our program, okay? Next time I will show you how to do the program. programming. Okay, this is a very simple example for using microcontroller. Now you can see that P1.1, P1.7. Okay, you can add more LED and resistors so that you can see a lot of LEDs flashing. Okay. Try to add more LEDs and resistors, and then connect them to P1.1 to P1.7. Okay. Then run the program. Then run the simulation, the model. Okay. You design to see the phenomena. Okay. After I finish the demonstration, I will send the recording, the video to you in WeChat. Okay, you can follow my steps if you are not successful now. Okay, that's all for today's lab. It's very simple, but just some steps, and you can follow that to take a look at our MCS 51. Okay, I will end my share and